Alright, let's take a look at circles. So in our last videos in 2.1 I kind of talked about how we're kind of jumping around right now. We're kind of just took like this concept of distance formula, midpoint formula, and stuck it in the beginning of the unit. We kind of introduced some stuff with the graphing calculator, starting to graph things, and then here unit 2.2 we're talking about circles. And even though we're going to use the distance formula, and even though there's some other stuff mixed in here, once again, this is kind of a standalone thing. This is a one and done unit 2.2. It's not going to build on itself besides this. So as we go through here, let's talk about a couple facts. An equation of a circle comes in two different forms. You have what's called the center radius form. The cool thing about the center radius form is that when you take a look at it, you can obviously just pull the center, the h of the center, and the k of the center of the circle just straight out of the equation when it's in this form, and you also can see your radius very easily. So whereas when you put yourself into what's called the general form, in general form you're in this x squared, y squared, format here equal to 0, and you honestly can't see anything about that circle. You would have to do some completing the square and moving stuff all around, and it's somewhat complicated, and we'll leave that for another time. So, like I said, the cool thing about the center radius form is that, when I look at this guy, I can clearly see where my center is going to be, so I can come over and plot the center of my circle. I can clearly see how much my radius is, so I can actually draw my radius, whether it be up, to the side, however it be, I can draw the radius and therefore get my circle. So, we come across our first situation here, and that's what's called the unit circle. And then it's called the unit circle because it has a radius of 1. So as we look at this guy, what I want you to be able to see here is you'll notice we don't see any h or any k when we look at the square. Well, that's because if we rewrite this, this is really x minus 0 squared plus y minus 0 squared is equal to 1 squared. So that means that my center, which is my hk, would be 0, 0, 0, 0, and my radius would be 1. Because 1 squared is 1, so you break it down and you get 1. So then we could come over here and we could draw our center. We could come out 1 unit in all directions. And then we could draw a sketch of our circle like so. And that's particular to circle like this, where you have where you're centered at the origin and you have a radius of 1, is called the unit circle. Just a little bit of tidbit information to introduce. But then we actually roll into what we're really going to be doing here, and then that is that someone gives you a center and a radius, and they want you to find the equation in center radius form. So let's do that. Let's take the equation. So our equation we know is x minus h quantity squared plus y minus k quantity squared is equal to radius squared. And by the way, you'll definitely need to know that formula for the test. Alright, so in this case right here, this is going to be our h, this is going to be our k, and then obviously that's our r. So will be x minus, our h value is negative 2 quantity squared plus y minus, our k value is 3 quantity squared is equal to 4 squared. Alright, so now we go through there and we simplify everything. So that means in this case here, 2 negatives make a positive. This becomes x plus 2 squared plus y minus 3 squared is equal to 16. And that right there is the equation of our circle in center radius form. Alright, so right now I'm going to go ahead and run through these also. If you want to go ahead and hit pause and try to do them on your own, and then come back and watch me go through it. If you get stuck or you get the wrong answer, that would be a good thing. So same thing here. We'll just let's go like this. This is going to be my h, this is going to be my k, and that's my r. So instead of writing out the whole entire equation, we know what it is now. So we'll just say x minus negative 7 quantity squared plus y minus negative 9 quantity squared is equal to the square root of 19 squared. We simplify. 2 negatives make a positive, so this becomes x plus 7 squared plus plus 9, excuse me, quantity squared, is equal to, and now remember that it's not so much that we talked about this with radicals and squares, it's not so much that the radical and the square cancel each other, but when we use properties of exponents, they undo each other. So we undo the square and the square root, and that leaves us with 19. Now, if you want to, you can always remember, if you want to test that out and see what it's going to be, because I'll tell you that that's a place where people make mistakes. Right there is people will go too far, or they'll double square, or they'll do something weird. So just remember that with your calculator, as soon as this thing pulls up, with your calculator, you can always test that. So we can always come here with our calculator and say second square root of 19, and then take that guy and square him. And so you can see that by calculation, it also comes out. So there's our equation of our circle and center radius form. We got one more. In this case here, this is our h, this is our k, this is our r. So we plug it into our equation. So this would be x minus negative square root of 13 quantity squared plus y minus 8 quantity squared is equal to the square root of 13 quantity squared. So hopefully what you're seeing here is something along the lines of like, a triangle of some sorts, but we don't need to worry about that even though we're talking about circles. So we get x plus the square root of 13 quantity squared plus y minus 8 quantity squared, and then once again the square and the square root undo each other and we get 13, and that'll be the equation of our circle in general form given the center and the radius. Alright, so we'll hit pause on this video and we'll move on and make a second video for the last part.